Hello, everybody. Let's go over some of these answers for the law sines and law cosines lesson 2 practice. Okay, before we start going over the actual answers to these questions, you might want to make sure that you have a scientific calculator handy. You can use one on the iPad and it works totally fine. However, switching back and forth between the screens is a little bit harder than if you're using a separate calculator. All right, let's begin. So in this diagram, we know two sides and we know one angle, and the angle is positioned between the two sides that we know. So this is a side angle side situation where consecutively we know a side length, then the very next angle, and then the very next side length. So side angle side, and the side and we're solving for a missing side, and we will use the law of cosines in order to find that. So let's set some stuff up. First, we have to label the triangle. I typically try to keep it as simple as possible, and I will just label this triangle A, B, C. Now, if you labeled your triangle in a different order, it shouldn't affect your answers. So the sides we know are, we're going to label them opposite of whatever angle we know. So angle A, the opposite side, the side that does not come in contact with A, is called side A. The side opposite of B will be side B, and the side opposite angle C will be little c. And now we can actually fill out our table that I placed in here. So we don't know anything about angle A, we don't know anything about angle B, but we know angle C is 39 degrees. We do know that side A is 9, and side B is 19. And what we're looking for is side C. I will put an X there for now, but we will delete it later when we get our answer. So looking at this, I don't have any numerator and denominator that's completely filled out. So even if you didn't recognize that you're going to use law of cosines before, at this point, setting up the law of sines would be worthless for me. I would... the sine of A over 9 would have the variable A, sine of B over 19 would have the variable B, and sine of 39 over side C would have the variable side C. So all of them are missing a variable. We can't use any of them. So we're going to use the law of cosines. Since we're looking for side C, we can use the law of cosine standard form that is solved out for C. That is C squared equals A squared plus B squared minus 2AB cosine angle C. Excellent. Now let's fill this out. And actually, I'm going to try to do it in as few steps as possible. So I'm going to take the square root in the entire right side and then just write C by itself on the left-hand side. We know that we can solve the entire right side, and then C squared will equal that, and then we have to take the square root of that number, but we might as well just do it all in one step. So C will equal, and then I'll write a huge square root. Okay. Side A is 9, so 9 squared plus 19 squared minus 2 times 9 times 19 times the cosine of angle C, which is 39 degrees. And I can type this into my TI-36X Pro and find the value of C. And I got C is approximately, now we're rounded to the nearest tenth, it's 13.27. So I will write that as 13.3. And just taking a glance up and looking at my triangle, that side being 13.3 actually does make sense. So that's a good thing. If you got an answer different than 13.3, you might be in radians. So check to make sure your calculator is not in radians. In this case, it gives you an actual kind of believable answer. I think it's like 18 or something. Let me check. Yes, it's 18.729. And if if you're not really paying attention, you might think, oh yeah, that's probably the answer, and just write it in. But in this case, that side C is 13.3. So you have to make sure that your calculator is in degrees. And the reason why you know to put your calculator into degrees is the angle measure is 39 degrees. Once you see that degree symbol somewhere in the problem, know that you're in good degrees. If you don't see that, or you see a bunch of pies lying around, then you probably need to be in radians for that problem. But here we have a degree symbol, so put your calculator in degrees. Cool. Okay, for the second problem, I notice that I have two angle measures that are complete in one side measure. Whenever I see that I have two angle measures, I think, okay, I can use the law of sines for this. And it's also great because not only am I using the law of sines, I know it's not an ambiguous case because I know two angle measures. So let's look at what we can fill out the table with. First, we have to label the triangle. So I'll just use my normal roundabout method, A, B, and C. And now let's label the sides. The sides have to be opposite of the angles with that letter. So the opposite of angle A is side A, and that's where our X is. The opposite of angle B will be side B. That's where 30 is. And the line on the top will be side C, and we don't know any of its information. So now we can fill out our table because we know what our angles are called and what our sides are called. Angle A is 54 degrees. Angle B we don't know yet, and we're not going to know. Angle C is 77 degrees. Actually, angle B we will find out. And then we have side B is 30. We don't know what side C is, and that one we're actually not going to find out, but we will find out what side A is. There's an X, and I will replace that once we have our answer. So we know sides A and B, and we know angles A and C. We don't actually have a full ratio that we can make out of any of these sides yet, but I think we can get angle B pretty easily just by subtracting. So let's do that. Okay, the triangle sum theorem says that all three angles in a triangle add up to 180 degrees. If angle A is 54 and angle C is 77, you can subtract those two angles from 180 degrees and find out that angle B is 49 degrees. So now we actually do have a full ratio, and it's for the B part of the law of sines. And I'm going to use the law of sines with A and B. I'm going to leave C alone. It did its job because now we know what angle B measure is, and we wouldn't know that if we didn't know what angle C is. So let's set up the law of sines. And we have the sine of 54 degrees divided by X equals the sine of 49 degrees divided by 30. Once again, using the table makes setting up these ratios really easy. So the first step I'm going to do is change the location between X and the sine of 49. And I will rewrite it after that step. There we go. And now we can completely isolate X by multiplying both sides by 30. Excellent. So all in one step in my calculator, I can type 30 times the sine of 54 degrees divided by the sine of 49 degrees. And when you type this into the calculator, sometimes you might have to put parentheses around just the top here as you type it into your calculator so that it understands that all of that is being multiplied by each other. And then the division part comes after, or at least it makes it look better if you have math print or a type of graphical math program like that. So I'm going to put this in the calculator, and I got 32.15874088. All right, too many digits. We need the nearest tenth, so that is 32.2. So that's what the X value is. Oh no, we have an angle side one here, but that's okay because there's a picture, so we know what this is going to look like. So there's no actual real threat of an ambiguous case. When they give you a picture, it's not ambiguous when you can see what the triangle itself is. So this one's great, and we have to label it, and then we can put it in the table. But I know I'm going to have to use the law of sines with it. So normal labeling system here. A, B, C. Now sides, side A, side B, side C. All right, we have angle B, side B, and side C, and we're looking for angle C. So we're not going to really use the A part of our table at all. Angle B is 112 degrees. Angle C is X degrees, but we'll just leave it as an X for now. Side B is 18, and side C is 8. Looks great, and we can obviously see which two ratios we're going to use in our law of sines. I'll say the sine of 112 degrees over 18 equals sine of x over 8. And we're going to solve for x. So I'll multiply 8 by the other side. So 8 times the sine of 112 degrees over 18 equals sine of x. And to get x completely by itself, we have to move the word sign over to the other side. It becomes arc sine. So I'm actually going to write this backwards now. X equals sine to the negative 1 power of 8 times the sine of 112 over 18. All right, now we're in one-step calculator territory. So I'm going to put this in and get 24.3356. So we will call that here. X is approximately 24.3 degrees because we're in degrees. Now, if I wasn't so sure that this wasn't an angle side side, and I wanted to test this, at this point I would subtract 24.3 from 180 to get its supplement. And that's 155.66. Now there's no way that can be angle C. That would be impossible. You can't have angle B be 112 degrees and angle C be 155 degrees. You are already way over 180 degrees. No triangle can have two obtuse angles. So since we know that that is the only possible answer, we'll go with that. All right, this is the last of our picture models. And this one has no angle measures, exclusively side measures. So if that's the case, you know you have to use the law of cosines. And this is a side, side, side. We have all three sides, but we have no angles. So that's a key in the law of cosines. So let's label our triangle and see which law of cosine we're going to use. I will call this side A, that angle A, this angle B, this angle C. So 5 will be side A, 6 will be side B, and 7 will be side C. And now I know that I'm searching for angle C, so I'll put my X there. Side A is 5, side B is 6, side C is 7. This is definitely not a right triangle. There's no 5, 6, 7 Pythagorean triple. So let's solve for X. So I'm going to use the alternative form of my law of cosines, and that is the cosine of C equals A squared plus B squared minus C squared over 2 times A times B. And I can substitute everything in. When I do that, I'm also going to move the word cosine over to the other side. So I'm going to take the arc cosine of that entire side. So let's see how that looks. C equals arc cosine of 5 squared plus 6 squared minus 7 squared. All of that over 2 times 5 times 6. And placing this into my calculator, I get 78.46. So C is approximately 78.5. That's good. It looks like it's about 78.5 for the angle. All right, don't forget the degrees. Well, I guess C is 78.5 degrees, but X is really just 78.5. I don't know. Holy smokes, this one looks a little different on your activity. We want to solve this whole triangle. So we're going to solve for every part of this triangle. It is not just solving for one side, so these will take a little bit longer. And let's see. Also, I took the liberty of making a table already and partially filling it out. And I also took the liberty of drawing the triangle and labeling each of the sides and each of the angles, just the way they did in the directions. So here's what it looks like. We had two angles, so I know it's only going to be one triangle. So I wrote it down, and let's start solving. So I like to start off with what's going to be the easiest first. And to me, the easiest thing to find would be angle C. Angle C is just going to be whatever 47 plus 52 is subtracted from 180 degrees. So let me write that down. Okay, so 180 minus 47 minus 52, and that equals 81. So 81 degrees will be angle C. Okay, we're definitely going to use the law of sines to find side A and side C, because we have B fully filled out, the numerator and the denominator, so that's going to be our scale factor. So let's solve for A first. So since we are solving for multiple sides, I'm going to use the variables A, when we're solving for A, and the variable B when we're solving for B. Here's our first law of sine filled out. So sine of 47 degrees over A equals sine of 53 degrees over 13. And I can swap the location of sine of 52 in A. So I can swap these two. So the sine of 47 degrees over the sine of 52 degrees equals A over 13. And now I can multiply both sides by 13. And 13 times the sine of 47 degrees divided by the sine of 52 is 12.06. So to the round answers to the nearest tenth, I will say that that is 12.1. And I'll write it into my table. Okay, the last thing we have is to solve for side C. And I'm going to use my B angle ratio again, because I know that side I just found is a rounded value, and I know nothing in B is a rounded value, so it will give me a more accurate answer. So let's go for it with the next proportion. Excellent. The sine of 52 over 13 equals the sine of 81 over C. And since it's the same step essentially as the last one, I'm going to do it all at one time. And C will equal 13 times the sine of 81 over sine of 52. And I can do this all in one step on the calculator. And the answer I get is 16.29, which is approximately 16.3. Excellent. I solved this triangle. I could fill out the side if I wanted to. Measure angle C is 81 degrees. C is 16.3. And A is 12.1. But if you fill out the table, it's the same thing. All right, let's move on. Okay, this one is named triangle XYZ, and then the sides are given as XY, YZ, and XZ. Wow. We have all side lengths, so I know I'm going to use the law of cosines in order to solve this, and we're going to solve for each of the three angles. When you're doing this and you're using the law of cosines, just keep using the law of cosines until you solve all the sides. That's the best way to do it. So I'm going to use the law of cosines to solve for like X and Y, and then just subtract those from 180 to find Z. but I don't like this numbering, so I'm going to change it. I'm going to change it to triangle ABC. All right, so I rewrote triangle ABC, where AB would be 29, BC would be 22, and AC would be 21. I'm just substituting all the X's with A's, all the Y's with B's, and all the Z's with C's. But I still don't like the way that this is written. I still don't like the way that we're calling the sides by the vertices that the segments are contained within, as opposed to naming them lowercase a, lowercase b, and lowercase c. So I'm going to actually change that. Now remember, when you change this, side AB actually becomes lowercase c, and side BC becomes lowercase a, and side AC becomes lowercase b. So here, let's look at that. Okay, that's much better. I like that. And now that I have this information, I drew a little triangle for us, and we're solving for the measure of angle A, the measure of angle B, and the measure of angle C. Only thing now I need is a table and maybe get rid of some of this work that we're seeing at the top. Let's see how this goes. Perfect. So in triangle ABC, C is 29, A is 22, and B is 21. And now it looks like all the other problems I've solved already. So because we can actually solve for any angle we want first. We can solve for A, B, or C. Really doesn't matter. I kind of like the alphabet, so let's start with A. So to solve for angle A, I'm going to use the alternative form for the law of cosines. The cosine of A equals B squared plus C squared minus A squared over 2BC. And when I substitute into this formula, I'm going to move cosine over to the other side and make it arc cosine. So I'll rewrite it like this. All right, the arc cosine of 21 squared plus 29 squared minus 22 squared, all of that quantity divided by 2 times 21 times 29. All right, this looks like a job for my calculator. And I put it all in, and I get A is approximately 49.067. So rounded to the nearest tenth, that would be 49.1. And it's in degrees. All right, let's find the measure of angle B. Why not? While we're here. Now, you might look at it and say, hey, we can use the law of sines here, but okay, so solving for angle B, we'll use the cosine of B equals A squared plus C squared minus B squared over 2AC, and solved out for the cosine for just angle B. B will equal the arc cosine of 22 squared plus 29 squared minus 21 squared all over 2 times B, which is 21. Oh, I mean 2 times A. Okay, 2 times 22 times 29. And I'll put that in the calculator. The solution is 46.148, so 46.1 degrees. Now, if we wanted to, we could use the law of cosines one more time and find the measure of angle C. But wow, wouldn't it be a lot easier if we just subtracted those two values from 180? Let's do that. So 180 minus 49.1 minus 46.1 is 84.8. And I actually did it out with many more decimal places. It became 84.78, which rounds to 84.8, which is excellent. Okay, I guess we could fill them out down here too. 49.1 degrees, 46.1 degrees, and 84.8 degrees. Cool, let's keep going. Oh, man. They did it again. Now they're calling it triangle DEF. So I'm going to change it to triangle ABC, just so our equations are easier. We don't have to convert our equations that we're going to use if we use a lot of cosines. Ooh, but this one, we have an angle and two sides. This might be an ambiguous case one. We might end up using a lot of sines. But either way, hey, let's convert all the D's, all the D's to A's, all the E's to B's, and all the F's to C's. Here we go. Oh, much better. Okay, so in triangle ABC now, same problem, just renamed those letters. The measure of angle C is 72 degrees, side C is 15, and side A is 12. And then I drew the triangle in. And I knew that this was possible because the side opposite the angle we know is bigger than the side A was. So this can't be an ambiguous case one. We can still check it after we put in our answers, but I know it's going to work out in our favor. Excellent. All right. So the first thing we are going to solve for is angle A. If we find angle A, then it will be easy to find angle B because we can subtract A and C from 180 degrees. And then we'd have at least the top of that ratio. So then we could find the denominator using the law signs again. So let's use the law signs with A and C. Okay, so sine of A over 12 equals sine of 72 over 15. I'm going to multiply 12 by the sine of 72 to move it away from the A, and then take the arc sine of that entire side. So let me write that out. So we have the arc sine of 12 times the sine of 72 degrees divided by 15, and then I can use my calculator to find that out, and it is 49.53 degrees. So here we go. 49.5 degrees. Okay. Let's do that ambiguous case check because we do have an angle side situation here. So I'm going to find the supplement of 49.5. That is 180 minus 49.5. And that would be 100 and... Wait, let me write it for you. 180 minus 49.5. And that would give you 130.5. Now, if it's possible for angle A to also be 134.5 as well as 49.5, we know 49.5 is correct, but it might be also possible for it to be 130.5, then we'd be in business. However, because angle C is 72 degrees, 72 plus 130 is greater than 180 degrees to start off with. Angle B would have to be a negative angle value, which is not something that we're going to find in the natural world. So there is only one triangle here. That's why I was so bold that I drew the diagram. Okay, but we can find what angle B is by subtracting 72 and 49.5 from 180 degrees. And I got 58.5 degrees. That's nice. Okay, so we know the numerator of that angle. Generally, when I solve this, I would have used way more decimal places than just one decimal place to try to solve for side B. But because we're only solving to the nearest tenth, we'll just keep it that way. So to solve for side B, and some of you might be thinking, oh, why don't we just use the Pythagorean theorem? We can't. It's not a right triangle. Pythagorean theorem only works for right triangles. So we have to use law signs and law cosines, even to solve for the third side in a triangle. Let's do it. I'm going to use C and B. So 50 sine of 58.5 degrees over, call it a little b, and that equals sine of 72 degrees over 15. Quickly solving this entire equation for b, you get b equals 15 times the sine of 58.5 degrees over the sine of 72 degrees, and simplifying that in a calculator, you get 13.4. So that's what length side b is. Let's just check to see if these are reasonable answers. The biggest angle is 72 degrees, and the biggest side is opposite of it, 15. the smallest angle is 49.5 and the side opposite is the smallest side, 12. And for B, it's the middle angle, 58.5 between the other two, and the side length is between the other two. That passes the eye test very well. I don't want to write it in all the lines down there. The table is completely filled out. Let's move on to the last problem. Okay, here we go again. It's triangle RST, and all our formulas are in A, B, and C. So let's convert it to A, B, and C. Oh, and they also did the RS for the side length. That's really T. Side T, and then RT is really whatever side S is. It's the missing one. And so let's convert that into A, B, and C. Way, way, way better. And also I drew the triangle, even though I wasn't 100% on this one. Actually, yeah, it's a side angle side. So you can draw this triangle. There's only one case. Here it is. We're going to use all of our information to solve for these things. Notice that we won't have a numerator and denominator to use law of sines. So it's a side angle side. You should kind of remember that that is useful for law of cosines. But even if you don't, you look at this, you're like, oh, I can't make a proportion that would work. So I might as well use the law of cosines. So we're going to solve for side A first. Let's set that up. Okay, I'll use a squared equals b squared plus c squared minus 2bc times the cosine of a. Now when I substitute the information I know into the equation, I'm also going to take a square root of the entire right side of that just to make it all one step in my calculator. No intermediary rounding. So hold on. And we have a equals, oh, I forgot the square root. Let's write that in right now. A equals the square root of this entire side. That way we can write a without the squared next to it. So the square root of 9 squared plus 17 squared minus 2 times 9 times 17 times the cosine of 55. And I can do that in my calculator. And I got 13.94580978. I'm actually going to save that on my calculator. It might be useful later. But I will write the answer as 13.9. That's fantastic. Okay, so we're solving for angle B now. You can see from the diagram, it looks like it is maybe slightly obtuse. Oh, I messed up this thing. Oh, let me fix that. Okay, so what happened is my diagram and my problem didn't really match up with each other, and that's kind of a problem. So I had to rewrite that angle B was 17 and angle C was 9. It honestly doesn't really matter which way I change that, whether I change the diagram or I change the problem itself. Just as long as I am consistent with what I do from now on. I don't have to go back and find the answers for part A because everything that had B and C in it had the commutative property available to it. So it really didn't matter if I did b squared plus c squared or c squared plus b squared. They're going to give me the same solution either way. Same thing with 2 times bc is the same as 2 times cb. So I don't have to go back and fix A. It's not wrong. I'm just from here on out, B is going to be 17 and C is going to be 9. Okay, so let's find angle B. I could do this a couple different ways. I could do it using the law of sines or the law of cosines. So let's do the law of, let's do the law of cosines. I like to keep going with the law of cosines when that's open to me. Okay, so let's write the equation. Okay, cosine of b is a squared plus c squared minus b squared over 2ac, and moving cosine over the other side, making it r cosine, and then filling out the thing. Notice I use a few more digits of my answer to angle A. I had said before it was 13.945800978. 4 decimal places will give me a more accurate answer for angle B, and if I have more accurate answer for angle B, I know angle C is going to be correct. So let me put this in the calculator and figure out what the measure of angle B is. Excellent, I got 93.086, so let's call that 93.1, and I'll put that in for my angle. Okay, I know that that is very accurate to 1/10. So I know my angle C when I subtract from 180 will be accurate to the nearest tenth as well. So let's find that out. Okay, upon subtracting 180 minus 55 minus 93.1 degrees, I get 31.9 degrees. And that looks great in my problem. So my A is 55, my B is 93.1, and my C is 31.9 degrees. When you use law of cosines like this, keep with law of cosines. Sometimes when you switch to law of sines, your answers get weird. And I remember getting a domain error one time, and it's just because the angle was obtuse, like this one. And if you start using law of cosines and just stick with it all the way through the rest of the problem and just maybe subtract to get the last angle, you'll be much happier that you did that. So that's my advice to you. Hopefully this helps, and hopefully you guys are all ready to take your test. So good luck. I'll see you soon.